So I'll be sharing the screen. I hope the screen is visible to you all. So in the block 2, unit 8, we are going to discuss is lean manufacturing process and applications. So lean is a philosophical way of working and which will focus on the removal of waste within the process. So whenever the production process is going on, this type of manufacturing process will help the organization to remove the waste from to have it will eliminate or remove the waste, and its main aim is to maintain smooth production flow continuously and trying to eliminate waste, and which will in turn result in increasing the value of activities in the production process. So lean manufacturing meaning and its aims, let us understand. The meaning of lean manufacturing, actually it refers to the application of lean practices, principles and tools for development and manufacture of physical products. And many manufacturers are using lean manufacturing. Why? Because this principle will try to eliminate the waste, it optimizes processes, it cuts cost, it will boost innovation and reduce the time to market in a fast speed or fast paced. It is volatile and ever changing global marketplace. So the many people, the phrase early manufacturing is synonymous with the meaning the removing the waste and eliminating waste is certainly a key element for any lean practicer. And to achieve the goal, lean manufacturing defines waste. Anything does not add value to the customer, that will be eliminated. And this process, this can be a process or an activity, product or service, or anything that requires an investment of time, money, and talent that does not create value for the customer is waste. And ideal time is underutilized talent, excess inventory, and inefficient process. These all are considered as waste by the lean definition. So how? Lean manufacturing will provide a systematic method for minimizing the waste within a manufacturing system, while staying within certain margins of control such as productivity and quality. Examples of lean production methods is in used today called SMED, that is single minute exchange of die, or TPM, that is total predictive maintenance, and Kanban, while examples of methodology that have been using lean manufacturing, which includes Lean Six Sigma and GMIC, that is define, measure, analyze, improve, and control. And these all have unique merits, but it would be fair to say that the style of management they were aiming for new, now generally thought of as lean only. So let us understand the aims of lean manufacturing. So the main aim of lean manufacturing is to our identification and elimination of waste, which will accomplish the unidirectional and continuous material movement known as production flow. And also it produces only what is needed, when it is needed, and production is pulled by the downstream workstation, so that each workstation should only produce what is required or requested by the next workstation. It should not produce which is not requested by the next workstation. And it should be focused on defect-free production lines. It aims for defects to be eliminated at the source, and quality inspection are to be performed by the workers as a part of the inline production process, and striving for perfection by continuously removing layers of waste as they are uncovered. So now lean manufacturing principles and ways of lean production. Let us understand the lean manufacturing principles. The 5 core principles of lean manufacturing are defined as value, value stream, flow, pull, and perfection. These are now used as the basis to implement lean. So let us, as we have said, 5 principles, that is value, value stream, flow, pull, and perfection. So we first will identify the value. So the first lean principle is identifying the value, so that it is the first step in the journey to become lean. And here it requires, this step is required for any business to define what customers value and how the products or services meet these values. So here value requires designing products to meet the needs of the customers. Whatever products you are designing or producing, it should meet the customer demand or customer requirement. If it is not for the purpose of customer, then it's a waste. That becomes lean. And removing manufacturers that do not specifically meet those needs, and also reviewing those features which are not under the needs of the customers. And by designing product to meet the specified needs, business will eliminate wasteful steps that may have been required for unwanted features. Design for Six Sigma is one method that can help business to identify the value. Here value means, this is the first step where it can be eliminated, the lean, that is waste, that is not required to the customer. Map the value stream. So here the second principle is mapping the value stream. A value stream is the complete life cycle of a product, and which will include the product's design, the customers consume the product, and disposal of the product. This step requires companies to identify and map the product's value stream. Here, lean tools like value stream mapping, it can be usually used to visually map out the entire product flow. Once the flow value stream is mapped, it will be easier to find and minimize steps that do not add value. Next one is create flow. The third lean principle is creating flow. Here, efficient product flows requires items to move from production to shipping without interruption. That is called flow. And here it can be achieved by strategically organizing the workflow. And under this, every factor from people and equipments to materials and shipping must be taken into account to ensure product seamlessly move through the production process. And establish pull. It is closely related to creating flow. And this is the fourth lean principle, which requires business to use a pull-based production system. And traditional production system use a push system, which starts with purchasing supplies and proceeds by pushing material to the manufacturing process, even when there isn't any order. Well, push systems are easy to create. They often result in large inventories and a significant amount of work in progress. A pull system, however, pulls a customer's order from the shipping department, which then prompts new items to be manufactured and signals that additional supplies need to be purchased. And lean manufacturing tools like Kanban can help business establish a pull system to control the flow of materials in a production system. The next one is seek perfection. So the final lean manufacturing principle requires companies to seek perfection. Why? Because whenever you have you want to seek perfection, may seem straightforward, and it's often one of the most difficult principles to successfully apply in the workplace. So here, lean manufacturing principles that are identify value, map the value stream, create flow, means from the production place to the place where it has to be organized to the workflow, it has to be moved in a proper way. So the shipping has to be done proper without any interruption. And the next one is establish pull and seek perfection. Next is waste of lean production. So lean practitioners have identified 8 ways. And that too, especially Toyota production system has laid out 7 waste or process and resources that don't add any value for the customer. They are unnecessary transportation, excess inventory, unnecessary motion of people, equipment or machinery, waiting, whether it is people waiting or idle equipment, overproduction of a product, overprocessing, or putting more time into a product than a customer needs, such as designs that requires high-tech machinery for unnecessary features and defects which require effort and cost for corrections. Next, we have elements of lean manufacturing. Under that, the first one is SMED, or setup time reduction, which will try to reduce the setup time and also changeover time, because it consumes critical working time and reduces proper utilization of machine and operator time. And the next one is Kanban. Kanban is a shop floor tool which communicates customer requirement from downstream to upstream worker. And once product is withdrawn from finished goods against customer demands to replenish the moved quantity, and it is replaced with colored card or electronically. This becomes a production order for the internal supplier in the upstream value chain. Total productive maintenance. Here TPM, that is total productive maintenance, promotes basic preventive maintenance job to operator itself, so the breakdown timing of machine is reduced. It also enhances operational efficiency of machine as workers does cleaning, lubricating, inspection, tightening activity of his machine. Batch size reduction. Lean manufacturing calls for smaller batch size production. The word single piece flow means it tends to one part at a time to be produced when operating for various types of product. In practical case, it is not possible in some cases, but minimum possible batch size should be selected. It helps in reducing waiting inventory of part. Lesser idle inventory means lesser working capital requirement and better financial efficiency. Cellular layout. In cellular layout production, equipment and workstations are arranged into a large number of small, tightly connected cells, so that many stages or all stages of production process can occur within a single cell or a series of cells. Next, Pukayok. And Pukayok means mistake proofing. It involves bringing a system which eliminates human mistakes in terms of quality, safety, and other process parameters to ensure quality and safety in the manufacturing lines. And the 5S. The 5S is a lean tool which consists of 5 steps. That is series, sit-on, sitesku, and shitsku. And taken from Japanese language, which aims to improve workplace efficiency. Next, quality at the source, which means the quality should be built into the production process in such a way that the defects are identified and eliminated at the source itself. Next, worker involvement. In lean manufacturing, workers are assigned clear responsibility for the identifying sources of non-value added activities and to propose solution to those things. Continual improvement. And a company never be perfectly efficient. So lean manufacturing requires a commitment to continual improvement, preferably a systematic process for ensuring continuous improvement. Kaizen. Kaizen means small improvement. To maintain continuous improvement activities throughout the organization, Kaizen culture should be created and maintained. Why? Because individuals, mainly operators, improvement in working conditions will be have safety, quality, productivity, and setup time reduction, or by some other small change for the betterment. And standardized work means defining the work and process instructions, which will help for the details of operations of or processors and parameters, which will in turn will reduce work cycle, and all work instructions should contain standard worker movement, actions, checkpoints for quality, safety, along with machine time and standard inventory. Next, visual management. So visual management facilitates everyone to be known about manufacturing targets, current status, deviations, etc. It makes information available for all regarding status of production lines, downtime, and also controls the process by defining limits of tolerance. Good and not good parts are also defined with different colors. Location of not good parts are generally defined by red color. Next, value stream mapping. Here, value stream mapping is a set of methods to visualize, display the flow of materials and information through the production process. And the main objective of value stream mapping is to identify value-added activities and non-value-added activities. Production leveling. Production leveling, also called production smoothing, aims to distribute production volumes and product mix evenly over time so as to minimize peaks and valleys in the workload. Any changes to volumes should be smoothed so that they occur gradually and therefore in the most non-disruptive way possible. And there are few other tools of lean manufacturing, and you can just have a glance on this. That is Anton, bottleneck analysis, Gemba means the real place, Jiroka, automation, just-in-time, cycle time, key performance indicators, overall equipment effectiveness, PDCA, Plan Do Check Act, and takt time. So it is a pace of production, manufacturing one piece every 34 seconds that will align production with customer needs or customer demands. Differences between JIT and lean manufacturing. Actually, lean manufacturing is customer-centric philosophy and JIT manufacturing is business-centric philosophy. So in lean manufacturing, mostly it is concerned about the customer requirement, customer demands. And in JIT, it is constituted only on the business profits and how problems can be overcome. That all will be discussed as per the business perspective. So benefits of lean manufacturing implementation. So the benefits we have is it increases productivity, product quality, it improves lead times, and it will have a sustainability, it will have some employee satisfaction, increase profits, reduced work in progress inventory, lower cycle times, multi-skill worker, and reduced defects. And we have lean manufacturing implementation strategies, under which we have senior management involvement, initiate with smaller projects, start with limited execution, and employ a professional to look after the implementation part of lean manufacturing process. And here, at every stage, senior management involvement is must and should to change or to commit or have lean manufacturing process in their organization. And at a time we cannot start, so we have to always start with the smaller projects and smaller chances for the better results with lesser risk. And start with limited execution. It will its implementation should be within limited area during start so that it can be monitored, corrected, and directed for further implementation. And employ a professional. Services of a professional mentor should be taken at least at the start. During conversion of conventional organization to a lean man organization, lot of issues will be raised and it should be handled professionally and they can be taken care with the use of expert. And so what are the obstacles that have been coming across in the implementing part of manufacturing process? So implementation part for the manufacturing process is lack of management support. If there is no management support properly, then the lean manufacturing processing cannot be done successfully. And lack of training, a clear understanding about lean throughout the organization, or the organization with knowledge of lean lacks, it cannot be implemented. And communication, resistance to change, no direct financial advantage. Next, we have Lean Six Sigma, and it will focus on the reduction and elimination of 8 kinds of waste known as downtime, and acronym formed by the words defects. Downtime means defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. And it refers to any method, measure, or tool that helps in the identification and elimination of waste. Next, Lean Six Sigma techniques we have that are Kanban workflow management practices, Kaizen practices, value stream mapping, and 5S tool. And the benefits of Lean Six Sigma we have is it can have streamlined, uh, simplified process, can increase control and company ability. That can also lead to more sales and revenue. And ultimately, all components of the business process benefits, that is employees, customers, vendors, and the company. And by preventing defects, companies save on the time, money, and human effort previously required. And what is the difference between Lean Six Sigma versus Six Sigma? See, Lean Six Sigma and Six Sigma are two related strategies which will always try to solve process problems, but both can help companies like make noteworthy improvements like in the points of quality, efficiency, and use of time. And it is possible by analyzing their process function. And both use the DMAIC phase method, and both are based on creating a problem-solving workplace culture. And Lean Six Sigma combines aspects of Six Sigma and aspects of Lean methodology to improve the process flow, maintain a continuous improvement, and achieve business goals. Next. Next, we'll move to the block 3, that is innovative manufacturing systems. So under innovative manufacturing systems, we have 3 units, that is technological innovation in manufacturing. So what are the different technology or the different technology innovations that have been taken place in the manufacturing process, and modern manufacturing methods. And the last one is automation and robotics. So let us understand technological innovation and innovations in manufacturing. As we all know that technology became the driving force across the world. And technological innovations have been changing the dynamics of business around the globe. And technological innovation is manufacturing industries have changed the pace of production rate with mass production. And technology has improved the efficiency, effectiveness, and quality of production. And there have been many evidences stating the improvement or importance of resource optimization and minimal global carbon footprints. And because of this, we got various industrial revolutions. And due to industrial revolution, there was a major technological changes in manufacturing, textiles, transportation, mining, and many other fields. And industrial revolutions had significant impact on the demand to supply ratio with automations and mass production, which has changed the world in the terms of economy and its living standards, and the major driving force for today globalization and trade it is. And the first industrial revolution in Great Britain has been taking place between 1760s and 1930s, which had marked the major innovations or inventions. Major inventions such as steam engines, water wheel technology, and many other, which had led to the foundation to the automation in production line. And as we know that Frederick W. Taylor is the scientific management, and Franklin and Lillian Gilbert motion study techniques are the major highlights. And Ford's production line management and design of interchangeable parts, in these products have brought the concept of resource optimization and lead time management. And because of this, we have got a in the innovations, that is manufacturing innovations have been taken place, and concepts of sustainability and innovative technologies for manufacturing. So we had a different concept that have been evolved, like four pillars of sustainability and corporate social responsibility, economical, social, environmental, and human aspects are being added to this. In addition to this, Potter's five forces theory. So like this, different theories have been evolved, and this all has brought a wider scope for technological innovations and various aspects relating to sustainability and innovative technologies for manufacturing, like sustainable manufacturing process, energy efficiency, pollution and waste management, and sustainable manufacturing and eco innovations are explained. So under this, the first one is sustainable manufacturing. And we all know that everything, whatever you are manufacturing, should be have sustainability. And sustainable manufacturing, it defines and optimizing resources and maximizing output where there is minimal negative impact on the environment. And it involves conservation of energy and natural resources. And many of the current technologies focus on improving renewable practices in the manufacturing process. And on this note, there are some of the major invention includes generation of electricity from solar energy, vibrations, tides, wind, etc. And cradle to cradle is one among new production chains which encourages by new innovations in technology and is becoming perfect definition for sustainable manufacturing. And sustainable manufacturing process, how does it take place? Production is a series of steps that have been followed for manufacturing a product, but sustainable production mainly focus on improving the production rate at very little utilization of non-renewable resources and limiting the number of steps while improving the product quality. In this perspective, technologies such as IoT, 3D printing, production line automation, technologies are being used for better efficiency and effectiveness. And BFS, that is blow fill seal, technology is used in manufacturing of IV fluids, is a perfect example for limiting the steps in production. And this aseptic BFS unit from the plastic container fills the liquid and seals it in a single production step. And the technology, the production rate up to 15,000 units to nearly zero wastage. And energy efficiency, pollution and waste management. And the main aim of manufacturing companies to attain maximum possible production and efficiency to increase their competitive advantage in the market. But on this note, they're concentrating on recycling and usage of renewable resources for the production cycle, which plays a crucial role. On the other hand, world organizations are focusing on zero emissions and development of renewable resources. Agrigold Private Limited has utilized agricultural waste in thermal power generation, making it cost effective. This innovation is reorganized by world organizations and has become a profitable idea. And we know energy conservation and waste management contribute to the cradle to cradle chain. In this technologies such as AutoCAD, simulation software solutions have changed the dynamics of designing, engineering and planning phase of production. Sustainable manufacturing and eco-innovation. And towards a green economy, innovation has been long been seen as central to economic performance and social welfare. It is increasingly recognized as a significant driver of economic growth. More recently, industry leaders and policymakers have also looked into innovation as the key to making radical improvements in corporate environmental practices and performance. For example, the European Union Environmental Technology Action Plan aims to accelerate the development of environmental changes and technologies and the eco industries. But while the Japanese government promotes the concept of eco innovation as a new field of techno-social innovation that focus on environment and people, the OECD defines that is the implementation of new or significantly improved product or process, a new marketing method or new organizational method in business practices, workplace organizations, or external relations that will have sustainable manufacturing and eco-innovation. So let us understand about the innovation. And there was much attention recently been paid to innovation as a way for industry and policymakers to achieve more radical, systematic improvements in corporate environmental practices and performance. And we know that many companies have been starting to use eco-innovative or similar terms to describe their contribution to sustainable development. And also a few governments are also promoting the concept as a way to meet sustainable development targets while keeping industry and the economy competitive. However, while the promotion of eco-innovation by industry and government involves the pursuit of both economic and environmental sustainability, the scope and application of the concept tend to differ. The scope, let us understand the scope of Japan's eco-innovation concept. The field they have given, the target, that is technology, business model, and social system. We have industry, social infrastructure, and personal lifestyle. When you talk about industry, we have manufacturing and service. So sustainable manufacturing, innovative R&D, and green ICT, and rare metal recycling. And service, whenever we talk innovative R&D, that is building energy management systems under the green ICT. And business model is green procurement for manufacturing, green servicing, and for services, energy service, and environmental rating, green finance. And when we talk about social system for the industry, under manufacturing, environmental labeling system, and green investment, and star mark should be given for the industry manufacturing process. And social infrastructure, under energy, technology, innovative, and R&D, superconducting transmission, green certification, top runner program or PRS Act, that is renewable portfolio standards, has to be done. And transportation, urban, when we look after this, and about the infrastructure, that is social infrastructure, innovative R&D, that is intelligent transport systems, green automobiles, and maglev. And business models, we have model shift, and social system, we have green tax for automobiles, next generation vehicles, and fuel initiative. Now we are using green tax, or that is nothing but EV vehicles, whatever we are using now. And personal lifestyle, we have technology, that is heat pump, and business models, green procurement, cool biz, and green finance. And social system, societal, that is telework, telecommunicating, or work-life balance. And the European or eco-innovation is considered to support the wider objectives of the Lisbon strategy for competitiveness and economic growth. The concept is promoted primarily through the Environmental Technology Action Plan, which defines eco-innovation as the production, assimilation, or exploitation of novelty in products, production process, services, or in management and business methods. Eco-innovation, meaning and dimensions, we will try to understand. And here we can see the changes in existing socio-cultural norms and institutional structures. Under that, we have facets of eco-innovation, targets, mechanism, and impacts are three facets of eco-innovation, under which the first one is target, which are the basic focus areas of eco-innovation. And these are products, process, marketing methods, organization, and institutions. Eco-innovations in products and process tends to rely on technological development, while eco-innovation in marketing, organizations, and institutions relies more on non-technological changes. And mechanisms, which are how changes in the target areas are made, and they can involve in modification of practices, redesign of practices, alternatives to existing practices, or the creation of new practices. And where it is an impact is on eco-innovation, which will affect environmental conditions. Experience shows that more radical changes in methods, such as alternatives and creation, usually result in higher environmental benefits. And the three main facets of eco-innovation, you can just here have a glance on the picture, which is displayed, that is eco-innovation mechanism. and eco-innovation targets. Under mechanism, we have modification, redesign, alternatives, and creation. And targets, we have products, process, marketing methods, organizations, and institutions. And it is mostly focused on primarily technological change. Later, it goes to primarily non-technological changes. Sustainable manufacturing calls for multi-level innovations. So here we can see it's like a closed loop like production, and which can be viewed as a facilitated by eco-innovation. And the steps in sustainable manufacturing are depicted in terms of their primary association with respect to eco-innovation, with innovation targets on the left and mechanism at the bottom, and the wave spreading towards the upper right corner indicate the path dependencies of different sustainable manufacturing concepts, how they are dependent. Next, focus of current eco-innovations. So when we talk about current eco-innovations, to better understand current applications of eco-innovation in manufacturing industries, the findings of a research article published by Priyanka Phatak and Mahendra Pratap Singh and Pankaj Sharma on sustainable manufacturing and innovation and need for future, which was presented here, and they reviewed a small sample of sector specific examples in the light of the above framework. That is, the sectors were chosen were automotive and transport industry, the iron and steel industry, the electronic industry, and the examples draw mainly on a questionnaire survey and focus group meetings conducted among leading companies in OECD countries as a part of this project. And you can just look at here a table where it is mentioning eco-innovation examples, industry and companies association, and eco-innovation examples. Industry and company association, we can look at their automotive and transport industry. When you talk BMW Group, Toyota, Michelin, and in eco-innovation examples are improving energy efficiency of automobiles, sustainable plants, energy saving tires, and self-service bicycle sharing system. And that are about automobile and transport industry. And we have iron and steel industry. There we can see Siemens, VI, etc. and Wilsab AVC. And here their eco-innovation examples are alternative iron making process, advanced high strength steel for authorities or automobiles. And in electronic industry, we have IBM, Okugawa Electric, Sharp, and Xerox. These are the companies which have eco-innovation examples. They are energy efficiency in data centers, energy saving controller of air conditioning, water pumps, enhancing recycling of electronic appliances, and managed print services. And this can be looked after here with the mapping the primary focus of example of eco-innovation. As you know, the mechanism is on the down and left side top, it is on the target. And modification, redesign, alternatives, and creation, they have given each thing. Next, modern manufacturing technologies. The advent of information and digital technologies has changed the dynamics of manufacturing process. And today's technological solutions are integrated with the internet, cloud electronics, and information technologies. It is known fact that information plays a greater role in making the process effective and efficient. And the integration of robotics, information systems, and cloud-based technologies has created new concepts in automation, such as machine-to-machine communications, which is leading to Industry 4.0. So Industry 4.0 is termed as the fourth industrial evolution. And in this evolution, smart machines, cyber physical systems, etc. are making greater value to the industrial value chain by making it effective and efficient. In reference to the potter's value chain, this technology is playing a greater role in creating a competitive advantage to companies via better product quality, effective mass production techniques, and the current day control systems have created a scope for flexible production line, which is based on real-time resource optimization. So let us discuss about what is Industry 4.0 and how it has evolved. Industry 4.0 is digital transformation of manufacturing in the fourth industrial revolution. Industry 4.0 is a vision and concept in motion, and with reference architectures, standardization, and even definition in flux. Most Industry 4.0 initiatives are early stage projects with a limited scope, and the majority digitalization and digitalization efforts in the reality happen in the context of third and even second industrial revolution technologies. But in essence, what is the new in this making Industry 4.0? That by making this, there is a possible leverage in existing data and ample additional data sources, including data from connected assets to gain efficiencies on multiple levels, transform existing manufacturing process, create end-to-end information streams across the value chain, and realize new services and business models, enabling more direct models of personalized production, servicing, as well as customer interaction, and cutting the inefficiencies, irrelevance, and cost of intermediaries in digital supply chain model where possible. And are some goals of Industry 4.0 in this customer-centric sense of increasing demanding customers who have value, speed, efficiencies, and value-added innovative services. Industry 4.0, the digital transformation, 3D platform, innovative accelerators, OT, and manufacturing meet in the transformation. You can just look at the picture how Industry 4.0 is going to affect, and you can see here cybersecurity, augmented reality, internet, that is IoT, Internet of Things, cloud computing, system integration, simulation, additive manufacturing, autonomous robots, and big data. This is the platform where digital transformation has been taking place, that is Industry 4.0. And from Industry 4.0 to the fourth industrial revolution, the first one, it's the mechanization, steam engine. This was the first industrial revolution, and steam power, new manufacturing, iron production, textile industry, mining and metallurgy machine tools, and steam factories. When we talk about the second one, that is technological electrification production line, mass production, globalization engines, turbines, broad adoption of telegraph, gas, water supply. And third one, computer integrated digital marketing, manufacturing, and PLC, robotics, IT and OT, digitalization, automation, and electronic digital networks and digital machines. And the fourth one is convergence IT, OT, autonomous machine, advanced robotics, big data analytics, IoT, and digitally ubiquity, cloud smart factory, machine learning, and AI and cyber physical. And these are the different from Industry 4.0 to the fourth industrial revolution. And you can see here from automation pyramid to industrial transformation with Industry 4.0, sensors and actuators, systems and internal services, connectivity, new service and ecosystem. Integration in Industry 4.0. So here we have Industry 4.0 vertical integration, 4.0 horizontal integration. So let's see first what is vertical integration, which involves connecting all business units and process within your organization, and in other words, converging operational technology at the production level with information technology at the enterprise level. With this integration in place, data flows between and is made available to all business units. This includes the factory floor, marketing, sales, customer service, purchasing, accounting, HR, quality control, R&D, and more. And Industry 4.2 horizontal integration, while vertical integration involves alignment within your organization, Industry 4.2 horizontal integration involves connecting all parts of your supply chain and this is include or involved. Next, Industry 4.0 horizontal integration, which while vertical integration involves alignment within your organization, Industry 4.0 horizontal integration involves connecting all parts of your supply chain, and this deeper alignment improves visibility, flexibility, and productivity, while also enhancing levels of automation. And here, horizontal integration applies within your production facility across multi-site operations and to third-party partners in a supply chain, both upstream and downstream. And components of Industry 4.0: system integration, big data analytics, simulation and virtualization, Internet of Things, that is IoT, the cloud, cybersecurity, autonomous robots, augmented reality, and additive manufacturing. And the same is here explained with the help of a picture, how each thing is used and where it is used. So when we talk about big data and analytics, full evaluation of available data is done with the help of that is example ERP, SCM, MES, CRM, and cybersecurity, operation in networks and operation systems, open systems, cloud, management of huge data volumes in open systems, real-time communication for production systems, industrial internet, network of machines and products, multidirectional communication between networked objects, and horizontal vertical integration talks about cross-company data integration based on data transfer standards, and simulation of value networks, optimization based on real-time data from intelligent systems, and augmented reality or by maintaining maintenance, logistics, and all kinds of SOPs, additive manufacturing, 3D printing, particularly for spare parts and prototype, and display of supporting decentralized 3D facilities to reduce transport distances and inventory, and advanced robotics, where autonomous cooperating industrial robots have been evolved. Benefits of Industry 4.0: increased efficiency in production, more potential for innovation, accelerated response to customer needs, reduced cost and high profit margins, quality assurance, fluid collaboration. And the same, all these advantages have been explained with the help of a picture. And Industry 4.0 challenges. So though it is evolving in such a drastic change and it's helping the production and manufacturing process of all the companies all over the world, but still it has certain challenges that have been included incorporating new technology or process into the organization. There are some other real-time challenges such as data security, trained human resources, team support, leveraging data because it's not possible, because it needs training and investment in new technology like Industry 4.0 does not indicate that you should rely on IT management to maintain systems. Instead, you can benefit from the frequent workforce training and team support. Having team support is highly crucial when moving to new technology, and the new model may be challenging to accept and adopt. And you must set clear expectations, state the purpose and the benefits of this investment, leveraging data and high cost. And later it has been discussed about the Internet of Things, intelligent robotics, additive manufacturing, and advanced composite materials. And the next chapter or next unit is modern manufacturing methods. So what are the different manufacturing methods that are modernly used in the manufacturing industries? Like we have heard about nano manufacturing, rapid prototyping, product prototyping. And we have modern methods. They are nano manufacturing, production support systems, computer aided simulations, adaptive control, mass production, product quality, computer aided simulations, waste reduction. So this all comes under the modern manufacturing methods. So let us understand what are those modern manufacturing methods. See, manufacturing method is a process for converting raw material into finished goods. And in general, any material is processed through different stages where they will be removing, forming, shaping, and assembling. The production process takes place. And since the Ford's model for production line, here there are many been concepts developed in order to optimize all kinds of resources in the manufacturing. And the main aim is to improve production and making it cost effective. The major management theories such as enhancements to process and can often create competitive advantages to the companies. And the major methodologies of production are just in time, just in sequence, lean manufacturing. These are the main methodologies that have been used in the production line. And some of the parameters in manufacturing are waste reduction, quality maintenance, and accelerating production. Guiding principles of modern manufacturing methods. So we have, as we have said, the related concepts related to the modern manufacturing methods are JIT, that is just in time, just in sequence, and lean manufacturing, inventory management. And most of the concepts concentrate on demand predictions for controlling waste and improving efficiency. However, estimating demands in the market is quite complex, and this has brought concepts of supply chain management, inventory management, that is maintenance of reserve stock levels. And the concept of modern manufacturing methods are drilled down to three major concepts, that is waste reduction, product quality, and mass production. So first we'll discuss about waste reduction. In manufacturing, reducing the waste to the maximum extent is manufacturing process is one of the crucial activities, because reducing the waste is the most important thing, and to simultaneously, along with reducing the waste, even the quality of the product should not be lost. Both has to be maintained equally. So when earlier manufacturing methods are allowed for waste and an excessive consumption of supplies in order to meet their goals for mass production, but the rebranding of modern manufacturing goes by new name that is called lean manufacturing. Earlier it used to be waste, it is lean manufacturing. So under that, just we have discussed lean manufacturing, just in time, Kanban, just in sequence, total productive maintenance, quick response manufacturing, cellular manufacturing, single minute exchange of die. So these are the waste reduction where it can, these are different methods that are being used for reducing the waste. For the waste reduction, quick response management, cellular manufacturing, 6 minutes of die. And the next one is product quality. So the second one is product quality. And this will continue tomorrow. So we'll continue tomorrow. Thank you.